Hello, welcome to my channel. We have been solving this past question papers. So right now I have this mathematics paper 4, mechanics, May June 2024. So we have already solved 4 questions in this exam. You can check my previous videos for those solutions. Question number 1, 2, 3, and 4 we have already solved. So we will be doing question number 5 right now. Okay, so a straight slope of length 60 meters inclined at an angle of 12 degrees horizontal. A bobsled starts at the top of the with this speed. The bobsled. Okay, it is given that there is no resistance. Find the speed when it reaches the bottom of the ground of the slope. Okay, so this is pretty straightforward question. Um, we have a inclined plane like this, whose length is 60 meter. Okay, and an object starts from here with already some speed, right? The speed is 5 meter per second. So when it reaches here, what is the speed over here? Okay, so basically whatever is the loss in potential energy, that has been converted into the gain in the kinetic energy. So let's calculate the change in the potential energy. That is going to be mgh. Okay, now how much is h? H is equal to 60 into sine of this angle is 12 degree, sine of 12 degree. Okay, so this would become m g and h is 60 sine 12 degree. Okay, now the change, the loss in the potential energy is equal to the gain in the kinetic energy. Okay, so how much kinetic energy has been gained? Uh, so it is half mv square. So vf square minus half mvi square. So we can write it as half m into vf square minus vi square, right? Vf is the speed over here, vi is the speed over here. Okay, so of course I can put these two things equal to each other. So m okay, let me do half m and vf we have to find out. Vi was 5, so it is 5 squared. So this is equal to m, and g is 10, and it is 60 sine of 12 degree. So m cancels from both sides, and it is vf squared is equal to 2 times this is the second, say this is 20 into 60 sine 12. Okay, and plus 25, this 5 square. And if I remove this square root, the square root becomes square root of this thing. Okay, so this all thing comes out to be 16.57 meter per second. Okay, so it started the speed of 5 meter per second. When it reaches down to the at the slope, its speed will be 16.57 meter per second. Okay, easy. Now question B, part B of the same question. It is given that instead of this coefficient of friction. Okay, so now on this inclined surface, the object is sliding down, but there's a friction here as well. Okay, so see what are the forces acting on this one. So one force is acting downward, and that force is mg sine theta. Am I right? If this angle is theta. Okay, now there's a resistive force, right? A resistive force, this force is equal to mu into the normal force, right? And mu into normal force is mg cos of theta. Okay, I hope you all agree with this thing. So the net force on this object is mg sine theta minus mu mg cos theta, right? And this force is equal to ma, the second law of motion. So if I cancel m throughout this equation, take g common outside, it's going to be sine theta minus mu cos theta equals a. Okay, a is equal to g into sine theta. Okay, and if I substitute the values here, a equals uh, g is used as 10. Am I right? Yeah, g we are using it as 10, and sine of 12 degree minus mu is 0.03 into cos of 12 degree, and this all comes out to be 1.7857 meter per second square. Okay, so this is its acceleration downward. Now, let's apply the equation of motion. So S equals VIT plus half AT square, right? We are using this equation because it has distance, it has acceleration and time. And we know the acceleration, we know the distance, we need the time. So that's why we are using this equation. Okay, so uh, distance is 60. Vi was 5 t plus half into acceleration. We found it 1.7857 into t square, right? So this becomes a quadratic equation 0.8928 t square plus 5t minus 60 equals 0. Okay, so let's try to solve this quadratic equation. So t is going to be minus 5 plus minus under the root 5 square minus uh, minus 4ac, right? B square, yes, minus 4 times a, which is 0.8928 into c. C is negative 60, so it's positive, and 60. And divided by 2a, 2 times a, 2 times 0.8928. Okay, so this comes out to be 5.86. The second time, the second answer is a negative time, which we just ignored it. Okay, so this is the so many second is our answer. Okay, so this is question number 5. Let's move on to question number 6. Okay, a particle moves in a straight line starting from a point O. The velocity of the particle at time t second after leaving is this much. Okay, so the velocity is given as k and square root of t minus 2t minus 8. And k is a constant. The maximum velocity was 4.5 meter per second. Okay, so maximum velocity occurs when at maximum velocity, the derivative of the velocity will be 0, right? Okay, so let's try to find dv by dt. Okay, so that is going to be k into half, and t power of half minus 1 is minus half, and minus 2, and that's it, right? And this is basically k over 2 under the root t minus 2, and this is equal to 0. We have to put the derivative equal to 0 to find the maximum point of the curve. Okay, from here you can see that k is equal to 2 times 2 is 4 under the root t, right? Or t is equal to k over 4 and its square, right? T is equal to k k square over 16. Yes. Now, velocity maximum is at this time, right? When at this time the velocity was maximum. Okay, so I will find the velocity at this particular time. So velocity is k, and t square root is k by 4 minus 2 times t, which is k square by 16, right? T is k square by 16 and minus 8. And this is given as 4.5. The maximum speed is given as 4.5. So we can solve this thing to find the value of k. Okay, so this is k square by 4 minus k square by 8 minus 8. So it equal to 8 plus 4.5. I can do that, right? Okay, so this left side will become k squared by 4, right? K square, no, sorry, k squared by 8. Yes, it is 8. It is equal to 12.5. So k is equal to under the root 8 into 12.5. And this comes out to be 10. Okay, so this is my part A of this problem. Okay, let's move on to part B. So k is known as 10, right? Okay, so from the part, answer the first part, we know that the velocity is given by 10 under the root t minus 2t and minus 8, right? Now we have to show that the at velocity is 0 when t is 1 and t is 8. So uh, at t equal to 1, when t is equal to 1, what's the velocity? It is 10. 1 under root is 1. I will not need to write. 10 2 times 1 is 2 minus 8. 10 minus 2 minus 8, this is 0. Yes, so it is verified. And similarly, at t equal to 16, velocity is going to be 10, and 16 square root is 4 minus 2 times 16 minus 8. So 10 times this is 40 minus 32 minus 8. Yes, it's also equal to 0. So this is also verified. Velocity is 0 at t equal to 1 and t equal to 16. Okay, now this is an interesting part. Find the distance traveled by the particle in the first 16 seconds. Okay, normally what we do, if I know the speed and velocity, speed and time curve, right? So if I need to find the distance in first 16 seconds, I will just integrate this thing and find the total area under the curve, and that will be the distance, right? But in this particular case, we are given that at time equal to 1 second and time equal to 16 second. At 1 second and 16 second, the velocity was 0, right? And it was maximum at somewhere 100 over 16, somewhere here. So anyway, so it means the velocity was negative, and it was 0, and it was positive, and it becomes 0 again, and something like this, right? So now if I try to find the area from 0 to 16, it will give me the displacement. So this negative area will cancel with some positive area. So that will give us a wrong answer. So what I need to do, I need to integrate it from 0 to 1, and this answer, I will take its positive value, and then add the integration from 1 to 16, and then I will add into it. So let me show you how do we do it. So let me say d1 is the distance between time 0 and 1. So I will integrate this expression from 0 to 1. And what is this expression? It's a 10 under the root t minus 2t minus 8, and it's dt. Right? So let's try to find this integration first. So it is 10, and integral, this is t power half dt 0 to 1 minus 2 t dt 0 to 1 minus 8 integral dt 0 to 1. Okay, so this is 10, and it is t power 3 by 2 divided by 3 by 2. Am I right? 0 to 1 minus 2. This is t square by 2, 0 to 1 minus 8 t 0 to 1. Okay, so this will become 10 times 2, 20 over 3. And then I put upper limit, 1 power anything is 1, minus lower limit is 0. So I just leave it like this one. Minus 2 cancel with 2, and t square, when I put upper limit, 1 square is 1, minus 0, minus 8, and again 1 minus 0. So this will be 20 by 3 minus 1 and minus 9, 8, so this is minus 9. Okay, uh, so it gives us a value of minus 7 by 3. Okay, remember I told you this is going to be negative answer. Okay, now what about d2? d2 is the integral of the same expression, 10 under the root t minus 2t minus 8 dt, and now I have to do from 1 to 16, right? Okay, the integral would be the same, so it is going to be 10 okay, t power 3 by 2 over 3 by 2, but this time limits are from 1 to 16, minus 2 t square by 2, 1 to 16, minus 8 t 1 to 16. Okay, so this is going to be 20 over 3. When I put upper limit, t 16 power 3 by 2, so 16 power 1 by 2 is 4. 4 power 3 is 64. And when I put lower limit, it is 1. Minus 2 cancel with 2. So 16 square is 256 minus 1. And minus 8 and 16 minus 1. Okay, I hope you are following me. So this will give me 20 times 63 over 3 minus 255 minus 100. Yeah, that's the 8 as well. Yes. So 15 times 8 is 120. So this all gives me an answer of 45. Okay. So the final answer is going to be the total distance is absolute value of d1 plus absolute value of d2, which is already published. So I'll let you put it this way. Anyway, so it is going to be 7 by 3 plus 45, which will give me 142 over 3. Okay, I hope you understood both the question and the logic behind them, the reasoning behind them. Okay, try to understand all these things. I hope these videos are useful for you. If you find them useful, then please subscribe my channel. Thank you very much for watching. See you in the next video.